of the battery, that is called forward bias. This entire section is called reverse bias because N-type material is connected to positive terminal of the battery, P-type material is connected to negative terminal of the battery. So that it is called reverse bias. So in this experiment, we are changing the voltage value and note down the current value. So this is voltage and this is current. And in the reverse bias, this is voltage, this is current. So by studying the variation of voltage with current in the forward bias, characteristics, and the second one is in the reverse bias, the voltage variation is studied with the variation of current. So the current in the forward bias is larger than the current in the reverse bias. So the first experiment is milliampere, the forward current. The microampere is reverse current. So why there is so much of change between forward current and reverse current? Because the reverse current consisting of the minority carriers. The reverse current is due to minority carriers, but the forward current is due to majority carriers. So that is the basic difference between forward bias and reverse bias. So forward bias will be in milliamperes, forward bias current is in milliamperes, the reverse bias current will be in microamperes. First of all, let us have our connections. Variation of voltages, that always shows the variation of current in the meter. So this is called forward bias. And the reverse bias is variation of voltages is studied with respect to variation of current. This is the table which we have to know. So variation of voltages, how this meter will be studied? In each scale 0 to 0.25 there are 10 readings. What is the value of one line, which is 0.025? So if you put 4 lines in the voltmeter, what is the reading? 0.2025 into 4, 0.01, 0.01, 0.025, 0.050, 0.075, 0.01. Fifth line 0.125. Because each line, the calibration, one line corresponds to 0.0. Here also 0 to 2.5, there are 10 scales. What is one line corresponds to? 0.25. This is 0.025. This is 0.25. So what is the value if you got 2 lines? 0.5. 0.25 plus 0.25. 4 lines. 1. 0.25, 0.25, 0.5, 0.75, 0.1. So this is the way of in which we have to fill up 0.1. So forward 0.1 means how many lines? 4 lines. So what is the value of current? 2 lines or 1 line?
1 line.
2 lines means 0.5. So, variation of voltage is 0.1, 0.5. Next one is 0.2. How many lines?
8 lines.
So this is 0.2. How much of current will be in the forward bias current? Milliamperes. 5.
3 lines.
3 lines.
0.7.
0.75. What is the next reading of 0.3? 12 lines.
12 lines.
1.25. So 1.25 milliamperes. 0.4. 16 lines. So in this way you can note down the readings. In the similar fashion, you have to change the voltage value in the reverse bias so that current is to be noted. You must note that the current in microamperes, why the reverse current is in microamperes, why the forward current in milliamperes, that is the viva question. Because the current due to minority carriers in a junction diode is called reverse current. The current due to majority carriers in the forward bias is called forward current. So you have to draw graph between forward current and the forward voltage. That is called forward characteristics curve. You have to draw the reverse voltage versus reverse current. That is called reverse characteristic curve. So you have to note down voltage and amps value in the respective biases. So the experiment will be try. Negative terminal is connected to positive to positive, negative to This is called forward voltage, forward current. So this is called linear region, straight line region. So that is called knee voltage in the forward bias. Reverse current. So reversing the connections, negative terminal is connected to positive. Positive terminal is connected to negative. That is called reverse bias. Reverse voltage. So this is the breakdown voltage. This is the new voltage. This is breakdown voltage at which the diode fades. That's why Jena diode is called. So because the Jena diode has more breakdown voltage, so the Jena diode is especially used in reverse bias. Forward bias, no difference between junction diode and the Jena diode. So resistance of a diode, static, dynamic AC resistance. This slope gives the delta I value, delta V value. So that what is delta V by delta I resistance? What is delta I by delta V? Conductance. So conductance graph will choose. So in the reverse bias, this is the new voltage, breakdown voltage. In the increasing region, this is called decreasing voltage.